Okay, so let's continue on. Now, before I jump in and do further, I want to review one thing with you in the book. I don't remember which page it is on. I think it's like, let's see if I have it here, 2.2 or something. I'm not sure if you read through it. Yeah, this part right here, it's like page 30, 36 in the book. The author talks something about round off errors. Okay, so when you do something like this, right? If you multiply price 4.35 by 100, and our expectation was you're going to get 435, but you get something like this. Okay, and like Python doesn't do that round up for you. So it's true with, I think, Java and C# as well. They don't do it. But like maybe PHP does it automatically. It would round up, really nicely. You just get 435 as expected. Python doesn't do that, and so you have to do that yourself. You have to round that off. And the reason why you get this is it's gets a little bit technical, but there's a reason why behind it. And it has to do with the decimal numbers. Now, I guess my question to you is, have you ever thought about how decimal numbers can be written in binary? Right? We always write whole numbers, like 1, 2, 3, 1,000. It's easy zeros and ones, but what about decimal points? Like 0.35 or 0.5, how do you write that in binaries? Okay, so that is why you would never get a perfect number in something like this. In certain situations, you would get something might be not even 0.99, it might be 4.8722220 or 5, something like that. And that depends on the decimal values. And that's because sometimes it's almost impossible to get an exact number with the decimal points. And so, again, this has nothing to do with the Python. I just want to explain it to you here, just in case if you ever run into this again in the future. So, I'll do one really simple exercise to show you here. So, for example, people like n is, 4.5. But I mean, just to show that the book is true, you can test it here. You can say 4.35 times 100, right? You see the number is 43.99999. If you do like 4.5 times 10, oops, you get a perfect number, right? Just expect it. Why not 4.49999, right? It's not. And the reason is because of the binary of numbers. So if you were to represent this in binary, like the number 4, we go like 0, 1, 0, 0, right? Right? So from the left side, from the right side, this is 0 position, 2, and then 4. So 4, and then there is a decimal point here. For the for the decimal numbers, it will also be just zeros and ones to the right. Okay, but every position here on the right side is you will start here. Like this is the 8th position, 4, 2, and then here is 1 or 0, right? Dot. From here on, the first position it's going to be half. Okay, 1/2. The next one is 1/4, 1/8, 1/16, 1/32, and so on. So that's how they're calculated in binary. So this will be like 1/4 here. This is 1/8, and then this is over here will be 1/16, and so on. So 1/16, 132, 164, and so on. So if you add all those numbers together to get 0.35, that number could be pretty long. 0.5 is easy because this is half, right? That's 0.5. So that means I just turn the 1 bit on. That's it. That's a binary representation of 4.5. If you get 4.25, you go, that's 25 over here, right? So 10010, 01. Okay, so if you add like 75, then you keep adding those numbers up until you match that 75. And if you put 35, just like that, it's so hard to get the number to be exact. So it's going to add a lot of numbers to get to that number here. And once you get the number 435, so that's kind of hard. So for example, if you do just the 5, that means these will be zeros. I don't care about these guys, and this is ignored. So just that one. So that's 4.5. Now I'll multiply that by 10. So then, what is the binary for 10, right? And the binary for 10 is, if you look at this, has 8, 4, so 1, 0, like that. That's a 10 for binary. And then you do the multiplication. Okay, so you multiply the 0, right? So if you do like, this is hard to read, but if you do it this way, you get the typical multiplication. So 0 goes into all these, you get 0. So the first line will be like 0, 0, 0, 0, 0. Right? But that would be here, for example. So 0 times 0, 0, 0. And then you go the next one.
Why is 1, 0, 0, 10?
Oh, this one here? Yeah, because it's the 8th position, right? So 8, and then plus 2, you get 10. So you turn on this bits here. If you turn this bit, you get 10. Yeah. I know, that's why it's confusing, but it's when you make it work, it's really fun, right? It's confusing, but yeah. So when you do the multiplication, then the next one, 1 times whatever it is going to get the same number. So this would be 0, 1, 0, 0, and then 1. So I'm going to remove the decimal here. If you look at this, it looks like that. And then the next one is the 0 again, so it repeats. It'd be like 0, 0, 0, 0, 0. And then the last one would be the same as the other one above. 0, 1, 0, 0, 1. So there's your multiplication. And I just add them up. So if I add them up, I get 0, 1. If I align them correctly, this is a 0. This is 1, 1, 0, 1, 0. Okay, that's the result. And if I'm not mistaken, if you check this number, you're going to get 45. Okay. Actually, we have to put a decimal number 1 decimal place, so like here, because there's 1 decimal place for that one. So this should be 45, and we can check it because this is, you can go like convert binary. Is that correct? Yeah. If we did it correctly, it should be correct. I don't have the program here, but if I type in binary here, convert, you get 45. Okay? So the decimal number of 45, and that's where you get 45. So if you get 0.35, this number gets pretty long. It's really hard to do. And you're going to get not the exact 435, but 434.9999994. So that's what's happening behind the scenes, guys. And if you like math, if you like computer science, these are the things that they usually do. Okay, all right, so we're done with that one. Just to make sure that it's clarified, if you ever encounter it again in other languages, that's how you add up the decimal portion of the binary system. starts with 0.5, 0.4, and then you double that every time. Okay, so for the rest of the class, why don't we go back to the assignments? And if you remember in Unit 1, we did the pseudocode for that. And Unit 2 is, pretty easy, I think, right? The Unit 1, this assignment gives you all these pseudocode and flowcharts. And this is usually, what should be done first before you actually do the coding. But these are pretty simple, right? Very simple. And so we can choose something like maybe something like number 3 here. Okay, so number 3. Do you remember this, the flowchart for that one? But even there's no flowchart, we follow the pseudocode here. So I'm going to copy this, which I can't copy it. Okay, well, there's still someone in the line to the zoo. So usually that is a loop, and we haven't learned loop yet, but I'm going to teach you anyway. It's a really simple one, and then we'll learn details later. We're going to calculate the entrance price. Actually, no, this is not fun. Let's do the other one. Let's do, this is too, a little bit too simple. Let's do the last one here. The high school ones. Okay? So, this was a fun exercise. So we're going to keep continuing registering students as long as the number of students doesn't exceed 4,000. So our capacity is 4,000. That's what this means, right? After that, we no longer can allow registration. And then we check the student. If the student's a freshman, then there's a $20 fee, and then plus the 100% materials fee, so we get that 120 fee. If you are the rest will just get 100 fee, including senior, juniors, and sophomore. But if you're a senior or a junior, then you get ice cream to go with that, right? It's not fair, but well. Okay, so let's do that in the code. So the first part. So I'm gonna do a new file. Okay, so I'm gonna close all these, and we'll do a new one. We'll write new file, and we'll call this one here. I don't know, students, I guess. Students.py. So instead of reading through a long list of students, I'm gonna just create a list of maybe like a couple of students, and then we'll loop through that number of students, not 100 times, not 4,000 times, but just 4 or 5 times, and then we'll check to see whether they are a freshman or sophomore or junior or senior. Okay, and the best way to kind of illustrate this is you can do an input. You can read input from the console, which is kind of tedious, but it can be done. Or you can just, create a list and do from there. So I'm going to do a list here called students. So it's a list, and I don't care what the student information is. We don't care about that. It's just that if you're a freshman, you get certain fees and so on. So just say that we go a list of their grades. So I'm just using numbers. So if it's a 9, maybe 12 for senior, and then 11, 10, and then let's just put 12 again. Do one more. Let's put another 10 here. So I have a list of about 7 students. And I'm going to loop through this student list here. So that's what the while part is, right? While still room to register. So that means we have a capacity of maximum capacity. You can do that, or you can do a max as a constant. We'll assume it's a constant equals to, let's just say we're going to just do 5. Okay, I have 7, but I'll just do 5 anyway. So when the max is reached, then we are no longer allowed to process, right? So you can use a while loop. While will be something like this: while condition is true, and then we'll say something like, well, you have to pick a certain number starting from 0 to 5. So we add another variable here. We can do the counter. We're starting from 0. It's a 0-based language. Well, we can do 1. Well, yeah, 0 is fine. So remember again that these are index positions. That means this is the index of 0, 1, 2, 3, 4, 5, 6. Okay? These are index positions. And so that means we only deal with 5 students. So the maximum number of capacity of index will be just 4. So this is 5 students. So from 0 to 4 only. So we'll say from as long as the counter is less than max. That's what it means, right? As long as it's no more than 4,000. As long as it's no more than 5. In this case, it's counter. But really, because we started from 0, so really to 4, right? 0 to 4. Then go ahead and process the first student. The first student is this counter here, starting at position 0. So you can do something like this. You can say grade equals students of counter. Okay, so we're going to get the counter position of the students list, which is 9. Right? So now we got the grade of the first student in this case, and then we need to determine what grade that student is in. Okay? So what's next? What should we do next? Anybody want to take a stab at it? Yeah, we need to check those, right? So what should be the next line here? What do you think? I mean, there's no one way. There's a lot of ways. But what would be a possible? What should you do next? If I give you this as an exercise, okay. So what? Now I got the grade. And it says the grade of the current counter at 0 is 9, right? So the next part is, what does it say? You have to charge these information, right? You have to display a message to display these. So you can say, if the person is a freshman, then there's an entry fee for that. Everyone, that's including freshmen, you also get a 100 fee for that. And then since you're not a freshman and you're not a junior or senior, sorry, you don't get ice cream, right? So you have to test for that. So that means you can start by testing either, I mean, any way you want, right? There's no rule. I can check, okay, are you a freshman, or are you a senior, are you junior, or are you sophomore? Right. So you can start from the lower number up. You can say, if grade, if you are a freshman, then the grade has to be equal 9, right? That's a freshman. Cannot be less than that, cannot be more than that. It has to be exactly 9. If it's 9, then you put here freshman. Then what do we say about freshmen? Well, you get a fee of $100 and so on. But this one says, okay, so you get a $100 fee, and then you get a $20 fee, but entry fee and the materials fee. So we can see that, okay, so I need to track those two. So that means somewhere up here, I need to put here as well materials fees. Let's do it this way. Is it's going to be $100 200. Well, this is like a constant because everybody gets it, right? So I can put here material fee. Everybody gets that. But the entry fee, we don't know that one because the only people who get the entry fee are the freshmen. The rest are 0, right? So we can say the default will be 0 for the rest because you only get the freshmen, you get charged for that. So if you're a freshman, then your entry fee would be $25. Okay, so you can say entry fee is $25. And we'll do the hard way first. Okay, and so you also get an entry fee. So entry fee would be, you got entry fee plus the material fee. So you can have something like this. Right up here also you have another one called total cost. Would be 0 for, no semicolons, right? It doesn't error out, but I guess be consistent. So if you're a freshman, you get entry fee 25, and then you get a total cost equal to the material fee plus the entry fee. And then it asks us to print this information out. So you can do, well, you can do it this way. You can print it out saying, so for example, you can do fee is, or you can put like freshman, and then you get charged at whatever the dollar amount was. And you can do this way. The fee was the total cost. That's for freshmen, right? There are actually better ways to solve this, but if you read it through, so usually you tackle one piece first, and then now you go to the next one, and then you see there's some redundant code. Once you see those repeating code, you can go back and refactor those code. Okay. So that would be the freshman, and we want to prove if that is true, then we can stop here for now and test our program. Before we do the sophomore, the junior, and the senior, we can test the freshman first, make sure that works. Okay, so, and then the loop here, we'll learn later. Just remember that when you do the counter here, you have to increase this counter. Otherwise, you're stuck at the 0 position in this loop forever. So you have a never-ending loop here. So then down here, you have to increase the counter equals to counter plus 1. Okay, and then again, the indentation is important. So make sure it's in the same indentation as the outer group here. If you put it over here on the right side like this, okay, it won't work. It will be completely different. This only gets counted if the freshman matches. If the freshman doesn't match, then again you go to an infinite loop. Okay, so it has to be out here in the loop here, in the first block. So let's save this and see what it looks like on the output. So I'm going to clear my screen. To clear your screen on the console here, you can do it a couple of ways. One, you can press the Control L to clear it. Or if you have a lot of stuff here, and you can also type, I think CLS, like the one on DOS, for clear screen. That should also clear it too. Okay, so wipes out that screen there. Okay, so I'm going to print this out, and if this is correct, I'm expecting to see two outputs because I have two freshmen. And it will stop here, so we're not going to get any more after that. And we'll see this is correct. And you'll see that the entry number will be different as well. Well, I mean, for freshmen, it will be the same. Right, so we have two freshmen, and they both are charged at $100 plus $25 fee, so you get that. And then we didn't test the other one, so they don't show up yet. So far so good, right? Okay, so we can then do the next one. And so this counter needs to be in here. We put it on the bottom, just in case you might forget. Then the next one here is the next group. So you can do the same thing, if grade. So I mean, you can do if grade equals 10. This is sophomore. Then entry fee is 0. There's no entry fee, so we omit that. So the total cost would be just the material fee, right? And that's it for sophomore. They don't get any special treats at all, just the material fee, and they're done. So we can print here sophomore, and then we have the fee of total cost.
Is there a reason you use another method instead of anything else?
Let me throw that question right back at you. Is there a reason why I should not use? Oh, okay, let me ask you, is it wrong to have it like this?
No.
Okay. And so you posed a really good question, and I'm glad you asked, because I was just about to ask you that. So, yes, there is a reason why you should put this into what's called the, right? Okay. So what's the difference between this and that? Both will get us a result. But why is it important to do this and not by itself? What do you think? It's more readable? Okay, well, that may or may not be, right? But that's I mean, it makes sense if you just read it, right? If that's true, else if that is true, else if, else if. Okay.
More efficient, so you don't have to, because if they are grade 9, then you don't have to check.
Exactly. That's the whole point. Because remember, you have like 5 elif blocks. Only one of those blocks gets evaluated. Okay. So if this is already true, I'm not going to go and evaluate the rest because it's like the short circuit stuff. If you do it separately, then if it's a 9, it does that. Yeah, that's true. Okay, this is separate if. It's going to check it again. Is it a 10? No. Is it 11? No. So you do the every if statements. Okay. If that's the case, then you don't want to do that because you're wasting CPU time. So therefore, you would do elif. Okay. If this is true, then just run this and skip the rest of the if blocks. And then you move to the next person and you check it again. If this is not true, ignore that. The only time the second block gets executed if the above block is false. Right? So like the circuit, the short circuit. So therefore, only one of these blocks will be executed at any time you do the loop here. So yeah, you get only one execution time. It's a great question. So we'll keep the elif here. And the sophomore, that you only get that. And then we have one more for the grade equals to 11. And then it says, 11 juniors and seniors get ice cream plus this fee. So you can do, so how do you do that? Do you check junior and then yeah, right? Or 12. Because you can't be and. Even though the instructions is and, you can't really do those. You can't be both, right? So this would be like if grade is equal to 11 or grade equal to 12. This is the senior, junior, and the senior. Oh, by the way, Python is so, we'll do later, but it doesn't work with OR, but Python is so cool. Remember, like in math, you always want to do this. If I say, if 5 is greater than 4 and 4 is greater than 3, then it's true, right? Okay. You can do this in Python. In other languages, you can't do it. In other languages, you have to say 5 is equal to 4, and like this, right? And 4 is greater than 3. Right? You have compound conditions here. And many times you wish you can just do, oh, why can't we just do this? Right? In Python you can. So this will be true because 4 is less than 5 and greater than 3. Okay? So for the AND part, you can do this way. If this is where an AND, it won't work on OR. If it's AND, then you can do something like this. You can say if grade is equal to 11 or grade equal to 12. I mean, it doesn't work this way, but if this were to be like greater than 11 and grade is less than 12, like that, you can rewrite this to say if grade, like that. So if grade is greater than 11 and grade is less than 12. Okay, so that's pretty sweet in Python. But in our case, so this is the case here, we have total cost equals to just the material cost. And then you have the pizza, ice cream. So usually you put ice cream in a separate variable. But again, I mentioned that there's lots of ways, so you can do it in many ways. We say junior, senior, and then this is the total cost. And then you have something like that, right? So there's the code for that. Let's see if this works. And if we're running now, we'll get, oh, this can be n, sorry, right, or, it won't work, it has to be or. So here we go, we have 2 freshmen, 2 junior, senior, and 1 sophomore. Is it true? 2 freshmen, 2 junior, senior, and 1 sophomore. Okay? So this is one way to do, there are lots of ways. You can see that it's repeating stuff. This is repeating, this actually, these are repeating, all these are repeating. The only difference is the freshmen get a plus entry fee, right? So you can rewrite this in a different way. because these are the same and the same. This part here is same, so you can say you can do differently. There's lots of ways. Also down here, the elif here, you don't have to do this part. Okay? Because again, if it's not this, it's not this, it's got to be one of these, right? So this whole part can be what? That's it, right? It's the catch-all. Okay? So it's redundant if you're going to check it again. Unless you want to check if it's a senior, you get something else, or junior, you get something else. But if it's the same, then that is the else part. And again, you can do all this here in different ways. Later on, we'll learn about functions. Like we'll learn on this util file here. You see that functions can make your code even much shorter and more efficient. Okay, because later on we'll say if grade is 9, print freshman. Else grade 10, print sophomore, or else print senior. And you only have one line in each of these blocks. Okay, it makes it much shorter. And this stuff is the same, so instead of writing this 6 times, I just write it 1 time in the function. Okay. And it's for the purpose of reusability. So that's one of the solutions for that pseudocode. We haven't learned well counter stuff, but these are very easy. Again, the structure is easy, right? Again, the logic is the one that you have to be concerned about. So even this elf block here, like you mentioned, why did you use separate if block instead of the elif, right? You still get the same result, no matter what. And in small cases like this, it doesn't matter. It's still going to be really fast. But if you deal with a huge data, then it can be really cumbersome. It can churn that CPU like crazy. So we don't want to do that. We want to avoid that as much as you can. Okay, any questions on how this was structured? How you take from the pseudocode to the actual code? Okay. So again, in here, if it's not confusing, you can leave it as is. If it's confusing, always put paren around it. Okay, it's not wrong. But do be careful when you use parentheses because they do take precedence. If you were to do something, if you want to evaluate one thing first, make sure you do that first before the other. So that could be a little bit different. And that is tricky when you get to something like this. So we'll do one more down here. Like say if I do a 1, B, 2, C, 3, right? So when you want to check something like if A is larger than B, or B greater than 0, and C is less than B. Okay, when you do something like that, if you don't put any parentheses around it, then it's going to evaluate from left to right. Okay, so what that means is it's going to start from the left side. We do this first. We get the value. Compare this against that. If this is one of these is true, then the rest is true, right? And the rest will be ignored. If it's important, okay, I want to do this first. Then that's when parentheses becomes important. I want to do that as a group. So do this first. We can do this first. It's fine. Do that first, and then do this. But then I want to do this together first, and get the result of that, and then use that result to go against this guy over here. Okay. So when that situation comes along, just make sure you are testing what against what, Otherwise, you get a completely different result, and you may wonder why. Okay. So last but not least, I want to show you about that short circuit. And so I want to prove that it's true, right? Okay. So I want to use this ABC here, and let me comment on this now, so we don't use these. Okay. So this is a short circuit example. So we'll prove that it is working, I guess. So I'm going to say if A is less than B, so do the AND first, and B is less than C. So if that is true, then we're going to print A is less than B, one line. Also print B less than C. No, that's not right. Okay. Yeah, I can't test that. Let's do it differently. I'm going to do up here. Let's do it this way. I'll do a function, okay? Just a function called A. I just put like for A, and then I'm going to put here A and B. So I'll do here return A less than B. Okay? So here, just put here, I'll replace this with part A. I put A and B here. So this is one part. Because it's a return the result of A minus B here. And before I do a return, though, I'm going to print a statement. I'll print this up there. I'm testing for this condition. And then I'll do another one for the second part, part B, B and C. And these are just arbitrary variables. It doesn't matter what they are. It could be anything. And I'll print this statement here. And I'll return the value B less than C. So I'll replace this whole part here. And so too many colors, we can take that out. Brackets. We say if part B, I'll pass in B and C. If both are true, you can say both are true. And then we'll just do an else here. Let's put false here for now. Okay, so let's see. Hope this works. Now, so this is our truth table, right? I'm going to call this function A here, passing A and B, and we know that A is put down here. So A and B, so A it is less than B, that is returned true. So we get this will be true. And then we need to check for B. I pass in B and C. B is less than C because 2 is less than 3, so this is also true. And we get true and true. We should get this statement printed. So what that means, when I check for part A, I'm going to have this statement printed, and then B, I get this printed, and then the third line would be both are true. That's the expectation. Okay? So if I click run, and that's what I get, right? So you check the first part, because that's true. It's an AND, so you have to check the second part also to make sure it's also true. That's why I have to run the second part, and you get the second part here, B and C, and then that's true, so therefore you get 3 statements printed. Okay? Now let's do the other way around. Let's say I'm going to force this to be false. So I'm going to swap the two. B first, A second, right? Again, the values here, these are just placeholders, doesn't matter. So maybe I'll put here, instead I just say, you know, part A, maybe it makes more sense. Part B, okay? So now swap the two numbers for the first part, and this is going to be false because B is 2, so B goes into A here, and then A goes into B here. So when A is not less than B, it's going to be false. So if it's false, then it only prints this part, and therefore it should not run this part because the end says, if this is false, just ignore the rest, right? So we're going to get part A, and then this is not true, so we're going to print false. That's the expectation. If it's true, that's what we should get, and then that's exactly what we get, right? So notice it did not print part B.
Why did it not print part B?
Yeah, because the first part is already false. Yeah, when I pass in 2 here, I swap the two numbers. So 2 goes in here, 2, and then 1. Because I replaced the numbers, basically. So when I do the evaluation here, 2 is not less than 1. So that's false, right? Does that make sense? Yeah, it's false. So therefore, this whole thing here is evaluated to false. So if it's false already, and say, and for this to be true, both has to be true. If one is false, then okay, you know what? Just this is regardless what this outcome is. It's going to be false anyway. So don't do it. So therefore, you see that it did not print the second part. Okay. So that's how AND works. Or it's similar. If I do that, you will see if I do it this way, then the first part we know is false because it's an or. Okay, well, maybe the second will be true. I don't know, right? So therefore, you have to check the second part. If the first part is false, you have to check the next one. If this is false, if there's any more to check, you have to keep checking until you find it. Okay? So if I save this and if I run it now, you will see that it should print all those 3 statements because it needs to check. It checks part B. B is false. Okay, A is false. Okay, what about B? It checks B and B is true. Okay, good. Then therefore it's true. It say both here, but just because we put both, it doesn't matter what the text is. And then it'll be opposite if I swap back to A and B. In this case, this is true. This is true also, but since truth is already found, just ignore this part. Okay? So when I save this, you see that it only prints the first part. It ignores the second part because it's not necessary. It's redundant. So that's the true short circuit operators, not just in Python, but in any language that supports that. Some languages may not support it. So like in Visual Basic, it supports both the short circuit and non-short circuit as well. So pretty handy in this scenario. Okay, any questions? All right, then I'm just going to review the assignment with you, and then we can take off. let's see if I have any questions in here as well. So I already put it here. Okay, you actually doing the employee, the hourly rate. It's kind of hard to read here, but it's the same what you did for the assignment in week 1. Okay, the only thing is that I ask you to do an input from the console. Okay, so you get the employee name and then enter the type of employee. It could be supervisor or just regular employee. You can say regular or supervisor. How you do it is fine. And then you test the employee type. If it is an employee, regular employee, you get the hourly rate from that. Otherwise, you will use the a yearly salary for that person, and then you get the also get the total hours worked from that regular employee, and then you're going to calculate the weekly pay for that employee, and then display that to the console. Okay, so that's pretty much that's it. And the exercise itself asks you to like read like a long list of people, but then this one we just do one like read from the input. So everything you run, you should be able to enter the data, and depending on the employee type, right? If this employee is a regular employee, then you have to get the hourly rate from the employee, and we'll assume that that's going to be entered by you because each employee has their own hourly rate. So just put any arbitrary rate. Otherwise, you should put a yearly salary instead of the hourly rate. So if it's a supervisor, then let's just say you get 80K, you put 80,000, and then the hours work here. This is only applied to regular employees, right? Because a supervisor there's no overtime pay, so it doesn't really matter for the supervisor. So this would be only applied to the regular employees. And then you calculate the weekly pay if it's a supervisor. Otherwise, the regular pay for regular employee plus the overtime, and then display that to the console. Okay, so it should work in every case. Okay, so those two types of employees. And if you get stuck anywhere, if you get lost somewhere or have any questions, just shoot me an email, and I'll be more than happy to assist you and give you some guidance. But I'm pretty sure it's pretty straightforward. So I look forward to seeing what you can do with this assignment. Be creative if you can. That's all cool. If you want to use a list like we did here, that's fine too. I don't mind if you want to do something like this, but you have to build a list, right? And since I should kind of show you how to do a loop here, if you want to do that, that's okay too. But because that's the same thing as reading from the input. However, if you do use a list, then when I see your code, run your code, I should be able to modify this list, and it should work for every employee, every case, right? So you can have like a list for the employee names, matching their hourly rates, and then matching the hours they work for that week, and so on. So you have 3 or 4 lists of that. If you are more familiar with the dictionary, that's also very handy because you have the key value pair, right? So employee 1, name, employee 2, and so on. So, all right, I think that's it. So I look forward to seeing it. And again, let me know if you have any questions. Otherwise, I'll see you guys next week.